Hello and welcome back. Today we're going to take a look at how you can utilize the strategy design pattern. This design pattern is useful because it allows you to dynamically swap out an algorithm which is being used by your application at runtime. This pattern is designed to create a grouping of algorithms and allow them to be interchangeable. In this episode we're going to take a look at some code which currently does not implement the strategy pattern so we can understand why it's less than optimal. Once we have taken a look at this, we understand why it's not necessarily the greatest. We'll begin to refactor it so it can utilize the strategy pattern. Let's go ahead and get started. The example today will be a simple logging class. It's very common within applications that you want to log to multiple different outputs. Maybe it's your event, the system event, maybe it's a database, maybe it's a text file, maybe it's just simply tracing to an output window, whatever the case may be. And this is a perfect example of the strategy pattern because depending on where you want to log, will depend on what logger you actually want to use. So if we look at our code right here, I've got a logging service, and I can create an instance of it, and I can say log message, and I can pass in whether I want it to be an event, a repository, or a trace. And if I bounce into the code here, you'll see that it actually does some code. Now, as soon as you come into the log message method, you'll notice I have a switch statement here. Whenever you have a switch statement, that might be an indicator that you might need the strategy pattern. Now, you'll notice here I'm saying that depending on my logging strategy, call these different methods. And say log to event, log to repository, log trace. I have the same thing for log error. And what happens? Now, if this was real code and non-demo code, chances are log to trace or log to repository or log to event would all have their own responsibilities. And they would have to do things such as maybe connect to the database or maybe connect to the event messaging system within Windows or something along those lines. And those needs are very unique and they don't necessarily belong in the main overall logging service class. So what we're going to take a look at today is how can we extract some of this stuff out, figure out how we can make this cleaner, make it so it follows more solid principles, and just make it so it can implement the strategy design pattern. So let's go ahead and get started. Now the first goal during our refactoring here is I want to create a new logging service which matches our same interface that our old logging service does so that we don't actually have to change our external code. So I want to go ahead and start off and I want to create a new class. We'll call this a logging service. And I'm going to go ahead and create a void method. Let's go ahead and copy this. We'll call this log error. And for now, that's all I'm going to do with this logging service. I've left my contract the same. But what I want to do now is I actually want to create an abstract class called logger. Now this abstract class is what all my individual loggers will actually implement. Now of course I could use an interface if I wanted to, but for this demo I did choose to use an abstract class. Let's go ahead and create a class. And our logging class will have a few methods on it. Log message needs to help to make this class abstract. So we're going to have two methods out, log error and log message. So let's go ahead and create our event log for this. We'll go ahead and have this implement our members. To save some fat fingering, I'm going to go ahead and copy and paste this code in. Now, this is not a real event logging class. So right now all I'm doing is debugging right line out a message that if this was real, it'd be going to the event logger. So let's go ahead and create our loggers for the other strategies that we have, which is repository as well as our trace window. So I now have 3 individual trace or logging classes. Now, if these were real, of course, they would do different things, such as probably spin up a database connection or try to figure out how to connect to the event logger, things like that. But just having an output right now will do the job. So I've gone ahead and I've created my base abstract class as well as my event log. Now, what I want to be able to do is actually implement this event log or all of my event loggers from within my logging service. Now, I could do what I did in the previous service, which is have a switch statement here, which will determine which logger to use, but that's really not going to work out well for me. So what I want to do is I actually want to create a private dictionary where the key is the strategy and the value is an instance of my logging class. And what I'm going to do is I'm actually going to create a method here that's going to be called define strategies. And what this is going to do is actually going to create instances inside of my dictionary for each of the various strategies I want to implement. Let's go ahead and fill this out real quick. Let's go ahead and create a constructor here that will call my define strategies. And now what's going to happen is every time this class is created, it will create this list of strategies for me. It will actually allow me to very easily, within a single line of code, call into them. So now I've replaced my switch statement with a lookup into a dictionary that will actually tell me which logger I'm actually using. But the nice thing is I've reduced the amount of switch statements, and if I need to create a new logger, a new entry, I can just add a new line here, similar to the other ones. But most importantly, I've swapped out the meat of the logic that was in my old service class, and I've put it within each individual smaller units of work that do only the one thing they're supposed to do, which is log to the event or log to the repository. Now, how would I write a test to verify that I did my job right? Well, let's go ahead and we'll create a new one called refactored logging service. And if I run this, after I've run, I should be able to look in the output window and see that, in fact, I've logged to each of the various logging loggers just by changing the input and having the switch statement gone and just using the dictionary. So as you can tell by looking down in my output window right here, I've logged to the event, I've logged to the database as well as the trace. And this tells me that I have not changed my signature. I've left everything the same. But what I've been able to do is refactor my logging service and all my logging code into small units of work that are more strategy based so that each one can do its own job and you can swap out the implementation at runtime. So I hope this is giving you a good overview of the strategy pattern, how you can use it within your own application, and how simple and straightforward it is to possibly even refactor your existing code to utilize the strategy pattern. Hope this helps. Until next time.